Hey guys, welcome back to Jason's home for lost old Marshalls. Look at this one. 1974 J&P, and this old girl has been well used. Right? Look at it. Pretty awesome. Yep. At this point, you might as well. At this point, you might as well just rip the Tolex off. Right, look at this. Okay, so we've got a hardwired mains. Here's our impedance selector, but it looks like it's been disconnected because there's none of the, they don't have the plugs on them. So I'm tipping that might be impedance. I have no idea what that is. We've got two holes on the back here. One's got a jack. God only knows what they're all for. If we go to the front again, let's have a look. Okay, it's obviously a 1959 Super Lead. Good old four-holer. Guy that owns this, Luke, has sent it to me. He's literally bought it kind of sight unseen. I think he went to see it. But, you know, all you can do is look at this and go, okay, it's an old Marshall. I don't believe he's even plugged it in, turned it on. Just basically got it sent straight to me to check it over. And once we open it up and have a look at the state of the thing, then I'll be having a yak to him about what we should do about this thing. Okay, we've opened up this old 1974 100 watt J&P, and yeah, okay, it's a mixed bag, that's for sure. What can I say? A lot of the stuff looks original on this board. Okay, so let's talk about the positives. Good old original mustards. These resistors, a couple have been replaced, like 33k slope resistor on the tone stack there is new. A lot of this other stuff though is all original. The old dog bone caps here, they're original, that's not. This has been hot glued in and put on, and that's that resistor on that cathode there, definitely not original. Now while we're down this end of the board, let's have a look at what's going on here. You can see these green stubs, these wire stubs. So we know, right, that these 68, they set up the low and high input. So when you're in the high input, they parallel together and you've got a 34k grid stopper onto the grid. When you go into the low input, that acts as a voltage divider. 68k and then 68k to ground, and your signal makes its way off to the first gain stage halfway between those two 68Ks. So it divides your signal in half, which is one of the reasons why when you go into the low input, there's a lot less gain. those have been cut, right? So normally you'd see green wires in a standard Marshall or whatever, they'd just be wired straight from these jacks here onto the board here. They've been cut in favour of shielded coax. That's not a bad thing, right? Not a bad thing at all. It's kind of done okay. It's all right. It's not awesome, but you know, it's okay. What's weird though is what's happening at this end, where we've got some ceramics here that are from the grids, by the look of it. Yeah, from the grids to ground. And this is kind of knocking out some high end. You know, I'm going to take all that out, right? Because, you know, well, I'm going to talk to Luke about it, but I think what we're going to be talking about is kind of getting this amp back to at least a stock Marshall, certainly to begin with. What else is going on here? This is weird, not connected to anything. God only knows what purpose that had. All of these pots have been replaced. In fact, most of them, I've seen this in a few old Marshalls actually. These are PCB pots. They've got pins, solder pins, to go into a printed circuit board rather than lugs, you know, like an eyelet, right? So, I mean, this one's not, right? This one's, that might actually be an original pot, that one. But everything else, you can see they've got the sharp edges on them, or the sharp ends, I should say. Right, so clearly over its life, all these pots have had to be removed, replaced, whatever. Good to see. Original Lemco. 5,000 picofarad bright cap. That's gnarly, and that's awesome. Yeah, that's cool as. Everything else here, like, you know, that looks all pretty stock. 220Ks have been pulled out. Now, give you a guess as to why that is. Look over here. Post-phase inverter master. Whenever you see that, right, pulled out, instant giveaway, because that's what the post-phase inverter basically has to shoehorn itself into that part of the circuit. If it's coming out on camera, you can see that this whole end of the board and right on the chassis down here, it's dry, but it's just covered in shit. It's like a glossy, it's a kind of thing that you see when a component, like an electrolytic capacitor or something like that, has just exploded. And if I tilt this, just be careful of the power tubes here. Let me tilt it up. Look at the inside of that chassis. I wonder whether that corrosion was as a result of that disaster. Might well have been, you know. Might well have been. Let's make our way down here. This is obviously our impedance selector, and the original Marshall impedance and mains selector have been completely disabled. All right, so this is now the impedance selector way over here. I'll flip this over and I'll show you what's going on the other side of the amp, because that's, you know, interesting. This post-phase inverter master is not done well. If I ever do these, I always use shielded coax. It's just good practice, right? This is just, that's a bit ordinary, really. What else we got going on? Moving down. Tube sockets, yeah, let's look at those, right? So these two look original, these two look like they've been replaced. That screen resistor is obviously not original. These green guys are. The grid stoppers on here look original, all four of them. Good old wire wound cement resistor put in here for a screen resistor, which I wonder whether, oh, who knows, right? I was going to say maybe that was something happened here that was responsible for that. It's kind of in that vicinity, so could well have been. Who knows? Down here, all right, so there's a couple of tag strip boards here. This has been hardwired into and this is basically hardwiring the power cable, and it's obviously this is the violet wind. This is going into the primary of the power transformer, and so that's 240, hardwired 240 volts, which is fine given where I am in the world. And they've used this other tag strip just to tie off these other parts of the primary, although that one's just literally fell off in my hand, so we'll clean that up. Right, so let's flip it over and I want to show you what's going on the top of the amp. Because it's pretty interesting. First thing you'll see, right, that is not an original output transformer. And I know Luke knew this, right, the guy that bought this amp. He had some pictures of it, so you know, it was priced into the deal. I have no idea about this thing. It's actually, would you believe, Southern Electronic Services Proprietary Limited, Melbourne, Australia. I looked these guys up. They still exist, but they don't do audio transformers anymore. You know, it's kind of industrial power transformers and so on. They don't seem to be doing kind of commercial grade audio stuff like this. And it says it's a 2K5 primary, and it's good that it's labelled. Right? Most often you see an aftermarket one-off like this or whatever, and you've no idea what it is, and they've got the secondaries are clearly labelled on here as well. So because the impedance selector on the back, which is this one, isn't it? Yeah, this one. You can see on the rear of the chassis there's no labels for it, so you've got no idea what you're selecting. I can see whoever sold this amp was pretty happy to run it in 50 watt mode. This is how it came, just with these two tubes, and when I pull them out, you'll see they are not a pair. Now, they might actually be matched. From a bias perspective, there's a chance, we can hope. Who knows? All of these filter caps are completely original. And on an old amp like this, you know, probably due for a recap, but, you know, we'll see. That's original, absolutely, and so is that. So is the choke. So, all in all, if you pick this thing up for a decent price, then it's probably okay, right? Because this can be brought back to all its former glory. I just need to talk to Luke about what we want to do with this thing, because we can move this back to, you know, a genuine, as original as possible, 100 watt super lead, maybe retaining the post-phase inverter. Okay, how do you know whether your old tube amp needs a recap? Well, one of the dead giveaways is the hum. And if you turn your amp on and bring it out of standby with the volume down, and there's a hum at the speaker output, you know, at the speaker, and it's, you know, loud, it can mean one of two things, right? It can mean that your power tubes are not a match set. So in a push-pull amp, if they have the same kind of bias point, they're balanced, if you like, the hum will cancel out if it's been caused by that, right? So if they're way out, and I suspected this amp because it's got two clearly not matched EL34s in it, but I measured the bias on them and they're bang on. So small mercies, right? Whoever put this in here either was lucky or actually found two odd EL34s where the bias point was matched. So there's this almighty hum coming out of this amp, and I'm going to demonstrate it, and we're going to see if we can hear it at the speaker output, because I've got this plugged into my cab, which is sitting underneath the bench here. And the post-phase inverter master is all the way off, right? So this is not hum coming from anything in the preamp, including the phase inverter, because this master is on 0. All right, so the amp's coming out of, well, it's warming up. You can see that it's on. And let's have a listen as it warms up. All right, I'm sure you can hear that. That is 100 hertz. Now 100 hertz tells you, or 120, right? If you're in the US and you've got 60 hertz mains, 120 hertz will tell you that it's something to do with the power, right? Because in a full bridge rectifier set up like this, once your AC, your mains, goes through the full bridge rectifier, the ripple that's left is 120 hertz or 100 hertz here in Australia. If you've got 50 or 60 hertz hum, it's probably the bias, because the bias just has a single diode, right? And it's 50 or 60 hertz. So if you've got hum coming from a problem with the bias circuit, it'll be 50 or 60 hertz. This is 100, right? So what am I thinking? I'm thinking these old filter caps. I just spoke to Luke, the owner of the amp. He told me this amp used to be used in a factory as a PA system and it was going to get thrown out in the tip, in the garbage. Someone thankfully saved it. Hadn't been turned on for 10 years until it was sold, right? And so Luke turned it on before. He did have a small playthrough, it, he told me, before he sent it to me. And I said to him, 10 years, hasn't been turned on. We could have a problem with the filter caps. All right, this old JMP here, which I have been busily restoring, we have completely recapped it. All right, so there's 6 new can caps in here, 1, 2, 3, 4, 5, phase inverter, another one under the board. But what I wanted to talk about is a 100 hertz hum that's been present at the speaker cab. All right, well, 120 hertz if this was in the US, 100 hertz here for us in Australia. And when you have hum, like this amp's got a post-phase inverter master, right? So I can turn this down to 0 and it eliminates everything here, right? It even eliminates phase inverter tube. That's all eliminated, right? And I've still got 100 hertz hum when the amp comes out of standby. If I had a hum present at the speaker cabinet while the amp was still in standby, right, which can happen, it'll be 50 hertz or 60 hertz if you're in the US, and it will be from magnetic coupling, EMI, that is coming from your power transformer and coupling into the output transformer. The output transformer is getting disturbed by that that magnetic interference, which is then getting converted into an electrical signal and coming out your speaker. This is not the case though. This is 100 hertz, which is double the hertz rate, double the frequency right, at the mains. And that is always a result of once your AC waveform has been rectified, there's 4 rectifier diodes here, right, and a full bridge rectification setup, peak at 100 hertz, plain as day. Tells me straight away that the amp, this 100 hertz hum is happening somewhere in this power setup, right, in the setting up the B plus line. And it can be from grounding problems, right? So checked all my grounds here on these filter caps, checked the ground here. I did find a missing ground on the preamp, by the way. So these pots here were not grounded. They should be grounded in a standard Marshall to the can cap that's underneath the board here. But I knew, that was just, fixing it up, right? But I knew that wasn't my problem, but I still sorted it. Checked all the groundings on here, it's all fine. And I'm still getting hum. Now, I have isolated the problem, and I want to demonstrate how I found what the problem is. And this is the first time this has happened for me, but it needs a new choke, right? The choke in this old JMP is screwed. It doesn't work. It doesn't do what it's meant to do. Now, I have a video already posted about what a choke is for in a tube amp like this, so you can go and have a look at that. I'd suggest if you really want to get into the guts of it, but in summary, it's a really important part of setting up the B plus line for your amp. And if it's not working properly, you'll have hum, and this is exactly what I have here. And I want to demonstrate how I located it, right? Because the art form, if you like, part art, part science in this stuff, is figuring out where the problem lies. And I want to show you what I do. So I'm going to bring the amp on. I've got the old choke wired in, right? So this is with the choke in place. And I'm going to bring it out of standby. The post-phase inverter master is completely off. It's coming out of standby. And you'll see, right? Let me just put the meter onto DC. Now listen. You hear that hum? It goes away. Hum comes, then it goes away, and then it comes back. All right, strange, yeah? It's annoying. I hate hum like that. I just cannot let this amp leave here and be shipped back to its customer with that. Just no need. So I just want to give you a reading here, right? This is the DC voltage on the mains filter cap, right? There's 2 mains filter caps. They're set up in a voltage divider, or a voltage doubler setup, I should say, right? So you get half of it here and the other half here. But that's basically the B plus voltage, right? Which is pretty much your plate voltage. Now, what I want to show you is you can use your meter to measure the amount of ripple that's still on your B plus, right? Because B plus voltage in a tube amp, it's a DC voltage. It shouldn't have any AC on it, right? However, on the mains, that's normal. You will have ripple at the first filter cap in your mains power supply. There's no worries there, right? It's before the choke, right? So if you can imagine in the wiring layout or the schematic, your AC signal, high voltage secondary, is wired into these rectifier diodes, and then straight from there, it heads over to these filter caps, and it's getting smoothed out. So there's still some ripple on the line, all right? There's ripple on that B plus line, that's normal. From there, it goes through the choke before it gets to the screen supply. And these 2 can caps here, right? That's your screen supply filter. This screen supply cap here, it connects to this guy here. This is the screen supply node. And the screen supply heads over and via these screen resistors here, gives us a voltage sitting on pin 4 of your power tubes, yeah? Now, at this point in the amp, you should have no AC. It should not be measured like that. 2.5, it's the same, right? Within 0.3 of a volt anyway, it's the same as the mains. Now, when I discovered this, because I was hunting this 100 hertz hum for fucking ages, right? Checking everything, checking all my groundings, checking my lead dress. I thought it was because these grid wires were too close to some of these wire runs here that still have AC on them. No, it wasn't any of those things. And then I finally got to this thing and I went, right, that is not normal. And what sits in between, this is our mains filter here, right? So this red wire heads off over here. It's the same point in the amp. The difference between here and here, how these 2 points are connected in your Marshall ST1, right, ST1 style board, is via the choke. And the job of the choke has two jobs, but the primary job of the choke is to block all AC. You should not have that there. So with that discovered, I pulled this choke out. I just pulled this lead out, and I temporarily, right, wired my Hammond. This is a 5 Henry. This is a kind of JC800 JMP replacement spec choke. I wired this in temporarily, and lo and behold, the 100 hertz has gone. So I'm going to wire that in permanently now. We will. I'm going to replace those bias caps with these guys, Sprague, and then this amp's ready to go. All right, well, this old choke has come out ineffective, and that new Hammond choke is now in. Right, bit of a pain in the ass to bolt that thing in, but you know, it's the glamour that comes with working on these old things. Now, what I want to show you guys is the AC reading at this point, right? So let me get the amp on. Right, so that's just the mains on. It's on, still in standby. And I'm going to bring the meter in here again. I'll start with it on DC so you can see kind of what's going on with respect to how we would normally look at voltages. But the choke, remember, right, it's coming in. This red wire here is one side of it, and the black wire over here is the other side. So it connects the B plus, the mains, right, filtered mains or the mains filter, P plus, right, over to the screen supply node. These two 10K droppers, right, screen supply, that goes to the phase inverter node, and so on and so forth. So, as we know, right, the choke is a really important part of the filtering network in your amp. Now, when I bring this out of standby, the first thing you can hopefully notice, or not notice as the case may be, there is no hum. Right, this amp is dead quiet now. So the post-phase inverter master is on 0. So let me bring this up, and you'll hear the, you know, the kind of the normal, I guess, the gain hiss, you know, the hiss of the preamp come in. Because I've got the volume here on about 7, right, on the bright channel. So, you know, cranking. All right, that's loud. That would be loud as right there. So with it wound back out, there's no hum. So let's have a look at the voltages at, that's the B plus supply, right? That's the mains filter. If I can get a decent reading on this thing, bear with me. 457, you can see the board's not bolted back in yet, right? So I'm still working on it. I've got to do those, I'm going to do the bias caps last. So, you know, plate voltage, right? Now, screen supply node. Okay. Couple of volts there drop, as you'd expect, because that's the DC resistance through the choke. Now what I wanted to show you is what's going on with this AC. Now, if I ground this, you can see it's 0, right? Now, that's pretty bloody close to 0. It's not dead 0. Of course, there's a little bit of ripple. Bear in mind, right, that it's going to go through the phase inverter. Yeah, so at the phase inverter node, we are down to 0. Right, basically no ripple on that. And here, you remember when I measured at this point AC with the old choke, we had about 2.5 volts of ripple on there. That 2.5 volts on the screens, right, which go to your power tubes, is what was causing that 100 hertz hum. So it's the first time I've seen this. The choke has lost its inductance, right? It's lost its property with respect to being able to reject AC. Right, bias caps, and we're done.